Hello everyone, this is Shasak and this is RepoForge, our project submission for GDSC Open Projects 2026. So the goal was to build an interactive visualizer for unknown repositories. This is the input page we land on when we start the project. First I will enter a random string, and as we hit the analyze code base, we get the error because the backend was unable to get the exact path. Now we'll enter the exact path of the repository. For testing purposes, we are testing the repository for this project only. So as you can see, the graph is rendered using React Flow and the positions of nodes are calculated using dagger layout. Instead of flat colors, we isolate the logic in a dedicated utility file to calculate the precise HSL values of nodes. Each node represents a file, and the hue represents the language in which the code of that file is written. For example, blue for Python, pink for TypeScript. But the lightness scales dynamically based on lines of code, so we can visually identify the heaviest and most complex files of the code base. The canvas is interactive. We can zoom in, zoom out, and we can drag, and we can even drag the nodes here and there as to our preference. When we click on the node, a sidebar slides in. It displays the local metadata such as lines of code, dependencies, and the exact path. We also get an AI analysis using Grok's model. If we click it again on the panel, you can see the sidebar closes and the node is deselected. You also have the option to go back to the input page if you want to test a different project. So that is all with the testing.
In the codebase of this project, I am Garv and I have developed the backend for RepoForge. This is mind.py. This is the brain of this project. It has two endpoints. We have used fast API library to set up the backend. Uh, this is the first endpoint, which is known as get graph. It basically collects the directory path from front end and traverses your project, gets all the file and sends the payload to front end for visualizing the graph. Here is a payload example. I have mentioned it in readme.md. Uh, the second endpoint is summary. It collects the file path of your file that you want to summarize, and it sends the summary like this. It the summary could be cached or it could be generated on spot via Grok AI. We have used Grok AI, and here is a list of some dependencies which we have used. The requirements of txt. UVCon and fast API are the basic uh, setup for backend, and .env secures the API key, and Grok is the AI which we have used for uh, calling and getting the summary of your files. Census.py is basically the code for traversing and analyzing your project directory. Till now, we have support for Python, JavaScript, TypeScript, Java, C, and C2P. Here are some common patterns for import. This is get ignore function, which excludes all the large and just some common files which you do not need to analyze for understanding the code base of the project. This is LOC function, which uh, receives the file and uh, checks for all the lines which have starting point like character or anything. It skips the blank lines. Here is get dependencies functions. It collects all the dependencies libraries from the header of any file. There are different cases for different type of files like JavaScript, Java and CPP, and for Python we have used abstract syntax tree, a library which is inbuilt feature for Python. This is the core logic of this census.py file. This is known as traverse. It mm, recursively traverses through your project directory and finds all the files and sends the payload with nodes and edges to the front end to make it as a graph. Now this is thalamus.py. It is basically the summarizer and the AI part we have integrated in our project. So you click on any file and it basically does two things. It checks whether the file you clicked was cached in memory or not. If it is already cached, we have used the hash function, uh, which checks for whether the file was already hashed or not. If it is hashed, it sends the same summary as it was sent for the first time. And if it is not hashed, it just sends the prompt and with the file to AI. Here we have used Grok and the model is Llama 3.1. It creates the summary and sends back to the uh, front end to show in the sidebar. This is initialization of database. It creates a table if there is no table already, and here ends the backend part.
So let's dive into a front-end code base. Our entry point is this main.tsx files, which then renders app component in strict mode. Our app.tsx is the routing and error management file. So when the stand path is empty, we render the input page, and when it is not empty, we render the graph component. And in case there is an error, so this tracks the error and reroutes the user back to the input page. Moving on to the input page. Input page has got two props, which is on-span function and the error message. In case there is an error, so we display it right here in the input page itself. We also have a few custom components like this text field component and this button component in the input page itself. And when the user has entered the repo path, it hits the button. So the button gets activated only when there is some text in the text field right here. And now moving on to the graph page. This is the main rendering engine of our graph. I am using React to handle the canvas, but raw data from backend can be a little bit messy. So inside this use effect block, we format the nodes and the edges that our backend returns. We call the backend using this function repo, which I have defined in services. So I've defined two functions, which is fetch repo path and fetch file summary. When in case the node is selected, we need to get the summary from AI. So this is the function that does that work, returning to the graph.tsx. So we have a few of handler functions like on node clip, the node is selected and the sidebar is set to be open. And when we click the remaining panel, the node is deselected and the sidebar is closed. We have this time delay for animation. So in case this loading is true, we render a different screen rather than the graph itself. We also have this back button in case the user wants to go back to the input page. This is also a custom component. Except that we have this sidebar which opens when node is set to be selected. This is our sidebar component, triggers when we select the node. So it hits our FastAPI backend with the request to get the summary using this function I showed before. So there's a bit of styling here and there, and we display the node title, node path of the file, and also the lines of code, dependencies, along with the AI summary here. If the AI summary is cached previously, like the node is clicked earlier while testing, so it also displays a little token of cached. And here is the part we display the summary. Also, I forgot to mention that here in node theme, we have custom nodes. So the nodes are colored using the HSL components and their extensions and the line